Today's lesson is lesson 5, activity 6. Sorry I couldn't be there today, guys. I'm home with a sick baby girl. I hope this video helps so that you can finish up your Delta math assignment, which has been moved from a due date of tomorrow, the 31st, to Friday, the 3rd, for 100% full credit. After that, it will open up to 80% credit until the end of the semester. Let's go ahead and get started with areas of regular polygons. Hold on a second. My stylus has turned off. All right. A regular polygon is a polygon with all sides congruent and all angles congruent. The area of a regular polygon can be thought of as the area of a composite shape. Let me go ahead and erase that down there. So what we're going to do is we're going to use the strategies that we learned in the last activity to help us to find the area of a regular polygon. Here we have a regular pentagon. One way that I can let you know that a polygon is regular is by calling it a regular polygon. In this case, because it has 5 sides, it is called a pentagon. Another way I could do so is I could mark all of the sides as equal, and I could mark all of the angles as equal like so. I could also go ahead and put the same number all the way around the sides and put the same number on the inside as well. But it is understood that these are the case when we see the word regular with the name of the polygon or just simply the word polygon. All right, let's go ahead and get started. Question A asks us to locate and place a point at the center of the regular polygon. Just go ahead and eyeball it the best you can. Then it asks us from the center point to draw line segments to connect the point to each vertex of the polygon. Go ahead and watch what I'm doing, and then go ahead and copy it on your paper. If you want your lines to be nice and straight, by all means, go ahead and grab the protractors in the baskets. All right, let's go ahead and describe the new polygons formed by adding these line segments. They're asking what kind of shape is this? Pause the video and see if you can figure it out. Well, of course, we have 5 congruent triangles. Remember this word right here, if you need it, means congruent. I'll just add it down here. But if you remember it, you don't have to write down the word congruent. What information do you need to calculate the area of each new polygon? Well, I think of the formula, so I'm going to need to know the triangle's base and the triangle's height. And what's my formula from this earlier in this lesson? I know that it is 1/2 times the base times the height. All right, let's go ahead and take a look at how I would then use this strategy of finding the area of this triangle to help me find the entire area of the regular polygon. Well, I could simply find the area of one triangle, then multiply it by 5 because there are 5 inside. Let me go ahead and switch back really quick to the picture. There are 1, 2, 3, 4, 5 triangles inside, so I would multiply by 5. All right, we're going to go ahead and skip question number 2. Question number 2 is asking us to generalize this to all regular polygons. The only difference is going to be what we multiply by. We can find the area of one triangle and then multiply by how many triangles there are inside. I'm going to also give you another method that you can use that you might find to be faster. All right, let's go ahead and take a look at questions number 3 and 4. So the first thing we're going to do in questions 3 and 4 is we're going to go ahead and we're going to put our center, which is at the end of this dotted line. There we go. And we're going to go ahead and we're going to draw our triangles. This way we can see how many triangles are inside. Don't forget, I'm going to go ahead and give you a hack on how you can figure out how many triangles there are without actually drawing them. There we go. And let me add the ones to number 4 as well. It's always a good idea when you are using a formula to start with the formula. So I'm going to come down here and I'm going to start with my formula for my triangle. And now I'm going to go back and I'm going to figure out how many triangles there are, and I'm going to start labeling the base and the height. I'm going to start here with the one with the dotted line as 1, and I'm just going to simply count. I'm using my laser as my eyeballs. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 triangles. I also want to show you that there are also 1, 2, 3, 4, 5, 6, 7, 8 sides. The number of triangles inside should match the number of sides of your polygon. Let's take a look at question number 4 to see if it works. We know that our sides should match our number of triangles. So first I'm going to count the sides. 1, 2, 3, 4, 5, 6. Right? I can label them like so. Let's count the triangles. 1, 2, 3, 4, 5, 6. They match. The reason they're matching is notice the base of triangle 6 is the side of the polygon. The base of triangle 4 is the side of the polygon. So this is why they match. All right, so we already know that the side of the polygon is going to go ahead and be our base. So there's our 2 bases. And our height in this case is going to be the dotted line. Our height is going to be that dotted line that we're given. So now we can go ahead and we can solve this formula right here. I'm going to write it down on my paper first, and then I'm going to go ahead and I'm going to plug it into my calculator because I can't do half of 12.5 in my head. It does come out to 93. To find the area of the polygon, I'm going to take the 93 and I'm going to multiply it by 8, giving me an answer of 744 inches in this case squared. Let's try another one. Always a good idea to start with the formula. The more you write it down, the more it gets stuck in your brain and you memorize it. I know from the colors that 40 is my base and that 34.6 is my height. Now, if I were to go ahead and move them around, I would not be wrong if I were to switch the blue and the purple number because multiplication is commutative, and which means the order that I place the numbers doesn't matter. To find the total area of the polygon, I'm going to go ahead and take my answer and multiply it by the number of sides, which gives me 4,152 centimeters squared. There we go. All right, let's try one more together. And on question number 5, let's go ahead and try by not putting in the triangles. I'm going to start once again with my formula. There we go. And I'm going to go ahead and I'm going to count the number of sides. I'm going to start here with the 8. 1, 2, 3, 4, 5, 6, 7. So there are 7 sides, which also means there are 7 triangles. You can count it either way. If you like doing the triangles, by all means, please do the triangles. All right, remember the base is the side of your polygon. So in this case, 8 would be my side, and my height is going to be the dotted line, which is the 8.3. Remember, if you switch them, if you had thought to switch them, you're not wrong. You're going to get the same answer anyways. That should give me 33.2, and I'm going to go ahead and do 33.2 times the 7 sides or triangles, which gives me 232.4 meters squared. I want you to go ahead and try the last one on your own. I'm only going to give you some hints here in the video. I am not going to give you the full answer. So you can fast forward through this part if you'd like, but please make sure you do have this one written down. All right, the first hint I'm going to give you is the formula. The second hint I'm going to give you is that this polygon has 5 sides or 5 triangles. And the last and final hint is the base and the height. All right. I'm also going to let you know that the area for the triangle should be a number in the 100s. It should be between 100 and 150, meaning if it's 90, 80, 70, 60 something, you should check your work one more time. Or if it's one above 150, 155, 160, 151, you need to go ahead and check your work again. Your overall area for your polygon should be 600 something, 600 and they should not be decimals. The number for the total area should be above 650, but below 700. So 640, 630, 500, these are numbers that we should all go back and double check. 701, 710, 715, we should go back and check those as well. All right, on the last page, I am going to go ahead and have you cross out question number 7. This question is dealing with using the formula and the process to help you find the height of the polygon, which is something that we can do. I'm going to go ahead and skip it because it's not on Delta Math. I do want to do number 8 with you. I'm not going to do number 9, but what I want to use the space in number 9 to talk to you about is the circle. I know that some of your Delta Math assignment is adding a part of a circle, and so I just want to make sure that you know the area of a circle formula. Remember, the area of a circle formula is pi times the radius squared. Remember, the radius is this part right here of your circle from the center to the end. The diameter goes in the full length through the center of your circle, and it is consisted of 2 radiuses. So if you know the diameter, all you have to do is divide it by 2 to find the radius. Remember that pi is the number 3.14, and so you can use that or you can use pi. I do want to go ahead and do question number 8 really quickly because it is going to let us find the area of a regular octagon one last time. This one is asking us to find the shaded region. There are 2 octagons in the picture, so I'm going to start with the larger of the 2 because that is where the shaded region is. I'm going to go ahead and I'm going to use my formula. Now in this case, I'm going to try to not write the formula down. My base would be 7.74 and my height would be, let's see, would be the 7 right here. I'm going to go ahead and put that into the calculator, giving me an answer of 27.09. I'm going to go ahead and then multiply that 27.09 times 8 because an octagon has 8 sides, giving me 216.72 centimeters squared. I'm going to have to use this answer to get my total answer, but it is not the answer. This answer right here would be if this inside part here was shaded as well. It is not shaded, so I need to find the area of the smaller octagon as well. Now the base of my smaller octagon is going to be 3.87, and the height, let me see, I have a lighter purple, would be 3.5. I'm going to go ahead and place that in my calculator. It gives me 6.7725, and then I'm going to multiply that number times 8 because it's another octagon, giving me 54.18 centimeters squared. Now I have to decide what to do with these two numbers. And since we are using it to figure out the shaded region, I have to decide, should I add or should I subtract? Well, I need to take away this one's area so that it would become like a hole in the other one. So I'm going to go ahead and subtract to find my answer, giving me my final answer of 162.54 centimeters squared. You have 3 assignments in that are going to go into the gradebook. Mathia Unit 2, Delta Math Lesson 5, which will close this Friday, November 3rd, for full credit of 100%, and Mathia Unit 3. Go ahead and use the rest of the time today to get one of those done. And of course, go ahead and take this paper, fold it in half, and glue it into your notebook. Hope to see you on Wednesday.